All right, physical science. It's our first official video. We've covered the chapter. All right, so up to this point, you guys have covered all the necessary information. You've done the key terms. You've done all of the review questions. You've made the practice quiz. So the normal progression, we probably would have already had our test by now. So I've been trying to keep you guys informed on Google Classroom to make sure that you are still reviewing and prepping and doing all the necessary studying that you should be doing to prep for this test. So remember, you guys still get the 1 page of notes, normal size, front and back. Nothing changes, nothing weird. The biggest change, of course, is that I'm going to be giving you all this information through a video. You guys are going to be taking the exact same test that you would have taken in class. It's just going to be me uploading a PDF, and you guys have to have that test open, and then you're going to write your answers down on a separate blank sheet of paper, nice and organized, nice and neat, and then you guys are going to use the Cam Scanner app, take a picture of it, go through all the necessary process of making that a PDF, and you're going to attach it back to the assignment that originally was the test on Google Classroom. All that information has been put already on Google Classroom. Your test is going to be on Thursday, and you're going to have a window that you have to complete the test in. Again, all that's on Google Classroom. That window is the equivalent of like you being in my classroom, taking the test, and then physically turning in your test when the bell rings or when it's done or whatever that looks like. So make sure that you finish it in that time period and you get it turned back into me. That's why I'm giving you guys over an hour, like an hour and 10 minutes or an hour and 15 minutes, whatever I had already written on Google Classroom. Should be plenty of time to finish, take a picture, upload the attachment, and click turn in. Alright, and then I'm going to get that on my end and go through all the normal, grade the test, and you guys will get your scores. So the one piece that we haven't done is that little study guide day where I'm going to ask you guys some questions and give you the little heads up about specific styles of problems you're going to see for the essay question. So that's what I'm going to do right now. Alright, so in the form of a video, you can pause it, write down the questions, answer the questions, go through the whole video, hear the questions and the answers, however you want to do this, okay? So, there we go. All right, first question I'm going to ask you guys. Here we go. The greater the mass of an object, and then you fill in the blank. The greater the mass of an object, and what you should say here is the greater its inertia, okay? All right, next one. One way to increase acceleration is by, give you a second, think about that, and that would be decreasing its mass. So one way to increase acceleration basically is by saying you're going to decrease how much that object's mass is. So smaller cars can travel faster, a little motorcycle can travel a lot faster than like a big semi-truck, which has a great mass, so it's going to need a lot more force to keep that object moving. All right, another question. Air resistance is a type of what? Air resistance is a type of what? And it should be friction coming to mind. So air resistance, an object falling straight down, it's going to be exposed to all those particles of the air that are going to be hitting up against it, and in that case it's going to actually be slowing it down. And you should remember, one of the things that air resistance works really well with is if you have a great surface area, then your air resistance is going to go up, it's going to slow the object down, versus if you have a small surface area, that object should travel straight down, usually pretty quickly, because it's not going to be coming in contact with all those particles. All right, another question for you. Forces can be added together only if they are what? And the answer we're looking for here is acting on the same object. So up on the board, you remember I would put a box and I'd have an arrow going to the right, arrow going to the left, and then those arrows are acting on the same object. So those would be forces that you would either add together or subtract. Remember, depending on the direction. So if we have forces all acting in the same direction, you add them together. If you have forces acting in opposite directions, you're going to subtract those. And that would be one of the things that you're going to have to solve for on your test. That's going to be your net force. Okay? All right, next question that we're going to put in here. Let's see. Okay. Any force that causes an object to move in a circle. So remember that. We talked about this, especially in the satellite section. We were talking about satellites have to orbit the Earth, and so there's your circular motion, and that's going to be centripetal force. So you hear centripetal force, you should think circle, circular motion. Remember that satellites are consistently being pulled down by gravity, but it kind of depends on how far in orbit they are. How far away from Earth's atmosphere are they? The closer they get, the greater gravity pulls on them. Therefore, the faster they would have to travel so that they're not actually pulled down through Earth's atmosphere. But if they are really far, then they just need a little bit of force to keep them moving, and that gravitational pull working down helps to keep that circular motion going and consistent movement. Okay. All right. Another question here for you. All right. Try to fill in this blank here. A measure of an object's what is a measure of the object's inertia? Again, a measure of an object's what is a measure of the object's inertia? And we should be saying mass. So a measure of an object's mass is a measure of an object's inertia. And so in other words, if you have a great mass on an object, then it's going to take a lot of inertia to either push that object from a stationary position or to slow that object down from an already mobile state that it may be in. All right, and let's see here. Let's finish up with one more question that I may have actually already given you that info in a prior description. But if you have one object that is being pushed, for example, on a table, then the force of friction acting on that object will go in what direction? So in other words, if you have an object traveling this way on a table, the force of friction on the table travels in what direction? It's going to be the opposite direction of what that object is traveling in. So if you have an object being pushed on a table to the left, then the force of friction is going to be going to the right, always opposite of whatever direction that would be. All right, and then just wanted to point out some of the things that you may be solving for your essay question. One thing I've already said is the net force. So you'll have to solve for net force on an object. Another thing you're going to be solving for is acceleration, which deals with net force and mass. You will also be solving for... Yes, you will be solving for momentum. So make sure you're dealing with mass and velocity for momentum. You, remember, could also have to solve, for example, for velocity. So if we're talking about momentum, which equals mass times velocity, what I'm telling you here is I may have you solve for momentum, meaning I'll give you mass and velocity. But what if I want you to solve for mass, which would mean I'm going to have to give you momentum and give you velocity. So you're going to have to change up the equation. To get mass by itself, you would divide both sides by velocity. And essentially you're going to say that mass equals momentum divided by velocity. So those are other things that be aware of you may have to do on the test. And the last thing that I want to make sure you understand would be on page 398, and 399, and all of that deals with the conservation of momentum. So right there, you're going to be given a situation. The book uses trains. You could have trains that travel towards each other. You could have trains that travel same direction, one faster, one slower, and they collide and come in contact. You could have a train that's stationary and another train hits it, and then what happens after. So everything is all about the conservation of momentum. And remember, with that, we're pretty much always dealing with masses that will be identical to each other. That we have a true transfer of momentum from one to the other. All right, so again, reviewing your key terms, reviewing all the calculations, go back through the chapter, back through every section, go back through all the notes that you've taken, rewatch this video, any questions that I gave you in this video, helpful tools for your test, and God bless you guys. Hope you're doing all right. I miss you guys. All right, bye.